Ignition sequence starts.
Good morning and welcome to a look inside the International Space Station Flight Control Room at the Johnson Space Center in Houston. This is where a team of specialists is always on duty to keep an eye on the operation of all station systems and assist the Expedition 67 crew members as they move through their daily tasks in orbit. We're back, but Station Commander Oleg Artemiev and his American, Russian, and Italian crewmates never left. They've been busy taking care of the station and supporting scientific research in dozens of experiments both inside and outside the station. And there was news this week about some future station crew members. Here, Shaniqua explains it all.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Shaniqua Vereen. This week, NASA updated astronaut assignments, demonstrated new science and technology, and got a look at a heat wave. On Thursday, June 16th, NASA announced that 2 NASA astronaut test pilots will fly aboard the agency's Boeing Crew Flight Test mission to the International Space Station, where they will live and work off the Earth for about 2 weeks. CFT Commander Barry Butch Wilmore, whom NASA assigned to the prime crew in October 2020, will join NASA astronaut Sonny Williams, who will serve as pilot. Williams previously served as the backup test pilot for CFT while assigned as commander of NASA's Boeing Starliner 1 mission, Starliner's first post-certification mission. As CFT pilot, Williams takes the place of NASA astronaut Nicole Mann, originally assigned to the mission in 2018. NASA reassigned Mann to the agency's SpaceX Crew 5 mission in 2021. The hot days of summer are officially here in the Northern Hemisphere, and NASA is monitoring the heat from above. NASA's Ecosystem Spaceborne Thermal Radiometer experiment on Space Station, or EcoStress, recorded some record-breaking temperatures this month. Built and managed by NASA's Jet Propulsion Laboratory in Southern California, the EcoStress measures the temperature of the ground, which is hotter than the air temperature during the daytime. Its primary mission is to identify plant thresholds for water use and water stress, giving insight into their ability to adapt to a warming climate. However, EcoStress is also useful for documenting other heat-related phenomena, like patterns of heat absorption and retention. Its high-resolution images, with a pixel size of about 70 meters by 38 meters, are a powerful tool for understanding our environment. This week, we answered the question, do astronauts have Wi-Fi in space? The Expedition 67 crew participated in a ballistocardiography session while wearing the SmartText 2 shirt. Ballistocardiography looks at body motion related to the pumping of blood by the heart. The Wireless Communication Network Wireless Compost 2 investigation is to provide a flexible and adaptable wireless network infrastructure to conduct and execute low-power, low-weight, and wireless experiments on the International Space Station. For this demonstration, Wireless Compost 2 operates several experiments, including an experiment to examine the impact of the space environment on the cardiovascular system. That's Space to Ground for this week. Thanks for watching. We'll see you next week.
Since the last time we were with you, NASA's SpaceX Crew 4 mission delivered 4 new crew members to the International Space Station to advance the scientific mission there and learn more of what we need to know to explore out beyond low Earth orbit in the years to come. Take a look as NASA's Kjell Lindgren, Bob Hines, and Jessica Watkins and European Space Agency astronaut Samantha Cristoforetti explain the goals of their flight and show their excitement about the prospect of flying on the Dragon vehicle for the first time.
Crew 4 is the 4th crew rotation flight for the SpaceX Dragon vehicle. Crew 4's goals are to safely and successfully get to the International Space Station, and then to spend the allotted time living and working in space, meeting all of the planned research and science and maintenance goals of the space station program.
We are all super excited about the opportunity to fly on a Crew Dragon spacecraft. That vehicle is a super complex, modern vehicle that enables us to get to space efficiently and safely.
My role as pilot on the Dragon vehicle is primarily to monitor and maintain the systems of the vehicle itself. To get a chance to pilot one of the newest vehicles on or off the planet is a true honor.
Yeah, getting selected for Crew 4 was amazing because it's an opportunity to go back to the International Space Station and experience again that transformation from being an earthbound creature to being this space-living creature. When you get to space station, the first thing that really strikes you is this feeling of weightlessness.
I'm so excited to revisit the space station. It was home for 5 months back in 2015. You know, we arrived on orbit, and really within a couple of days, my brain adjusted to the idea of floating. Not that I was good at it, but the novelty of it. I think that the fact that our brains can adapt to something that is so novel, so different, something that we're completely unaccustomed to for all of our lives, and that it can just adapt like that is absolutely amazing.
The International Space Station is a national laboratory built to do science.
The connecting element between all the experiments that we do up there is the space environment, and specifically weightlessness, microgravity, as the scientists like to say.
When you're dealing with complex systems, one way to learn how they work is to start removing variables. We're able to do a lot of that down here on Earth, but one of the things that we have a challenge doing and we can't do is remove the effects of gravity. And so by taking things to the International Space Station, we can remove that and we can see how these complex systems work, how things grow, how they develop. We do so much research up there that not only helps technologies and development down here on Earth, but it is also aiding NASA's pivot back into deep space exploration.
The work that we do every day helps us to better understand how the human body changes in weightlessness, and to understand how to do the operations like spacewalks and robotic arm activities that are necessary for us to be successful in lunar orbit, on the lunar surface, and on our way to Mars.
We get this awesome opportunity to be representatives of humanity, of all of you, and we don't take that lightly. We're super honored to have that responsibility and are excited about sharing the journey with all of you.
Along with work on science experiments and station maintenance, most International Space Station astronauts spend some of their time sharing the experience of being in space and talking to students about scientific concepts. In this news demonstrations episode, astronauts Megan MacArthur and Aki Hoshide explain the geometric concepts behind the strategic choices that were made in space station design, choices that helped make sure every cubic inch of it is used efficiently.
Welcome to the International Space Station. I'm astronaut Aki Hoshide.
I'm astronaut Megan MacArthur. Today, we're going to discuss how engineers design space station modules so we can use the entire volume to live and work.
What is volume? Glad you asked. Let's go check it out. Area is defined as the two-dimensional space occupied by a flat shape or surface of an object, whereas volume is the amount of space occupied inside a three-dimensional object.
Length times width will give you the area of a square. Take the area of a square and multiply that by its height to get the volume of a cube. For example, here's a cube that is 2 meters long by 2 meters wide by 2 meters high. Multiply those dimensions and you get 8 cubic meters of volume. But that's only one way to calculate volume. Cones, cylinders, and spheres all have different formulas to calculate their volumes. To calculate the volume of a cylinder, we take the area of the circle, pi times the radius squared, and multiply that by the length of the cylinder. In the Destiny module, we have a pressurized volume of approximately 106 cubic meters, or 3,700 cubic feet. That's a lot of space for us to live and work.
Destiny is the primary research lab for U.S. payloads, supporting a wide range of experiments and studies contributing to health, safety, and quality of life for people all over the world. Engineers designed these cylindrical modules for astronauts to utilize the entire three-dimensional space.
So you've learned that Destiny is a cylindrical-shaped pressurized module, but inside the space you can see that our interior space is a little bit more like a square. So these racks are designed to fit against the walls of the circular cylindrical module, and so the back of the rack is curved and the front of the rack is straight. And so we can keep a variety of different kinds of experiments in different racks, and we can also use the ceiling and the floor just as easily as if it were a wall. So one of the places that we store some of our stuff is in the ceiling. You see we have these different kinds of bags that we store things in these different kinds of cupboards. We also can keep our medical kit up here out of the way. So if anybody gets a cut or a scrape or needs some medicine, we have different packs in here that have all the different things that we might need while we're up here. I can also use space in the floor. We actually have a window that's in our floor that looks straight down onto the Earth.
You learned a little bit about the importance of engineering and utilizing volume aboard the space station today. Use the corresponding classroom connection to learn more about area and volume and challenge yourself to redesign your own home and classroom for life in microgravity.
Maybe one day you will be an engineer designing rooms for us up here in space. See you next time.
Although NASA is getting ready to return astronauts to the moon on upcoming missions of the Artemis program, geologists are still learning about the moon from soil samples collected there almost 50 years ago. A team of lunar sample processors and curators at the Johnson Space Center in Houston, along with Apollo 17 astronaut and geologist Harrison Schmitt, have been opening lunar samples collected on Apollo 17 to be studied using the improved methods of the current day.
The first thing we do is we put it in this catapult-looking device that you see here. We call it the rocket launcher. The end caps are taken off of the drive tube, and then threaded metal rods with plates on the end were actually inserted into either end. Then the sample is picked up from the rocket launcher and it's put into this device over here with the wheel on it. As that wheel gets turned very slowly, the threads engage and the rod starts to move, and it pushes the sample out.
That core was collected by Gene Cernan. As I was working on the edge of a crater nearby, one of the most important tools that we had was this core tube, double drive tube, and you could drive these into the surface. Now, still very difficult. It was the best we had, and we got quite a number of very good cores that are giving us new information, not only about the nature of this debris layer, but also within those cores is the history of the sun. It was anticipated early on in the Apollo program that analytical technology would mature, would become much more sophisticated with time. that we could gain new information from the same old samples. And it makes it very, very exciting for everybody. In fact, Apollo never ended for lunar scientists.
Our analytical techniques have gotten to the point where we can actually detect the water that is in some of these ancient lunar rocks. We've actually been able to constrain that there is a common history and a common source between the Earth-Moon system, which is what we had learned previously by other studies of the Apollo lunar samples. That we have X-ray computed tomography, or XCT now. This is a way for us to actually look at the three-dimensional structure of a sample where we could not do that before. There's a whole industry of engineers who are studying how to extract resources from the moon. And so one of the things that we want to do during Artemis is actually test out some of these new technologies and see how effective they are at extracting the water and these other materials. Thinking forward to Mars, we've only ever sent robotic missions to Mars. And so when we send people to Mars, these are things we're going to have to consider.
So this core has a multitude of information to give us, and we're, as you can tell, I think, all of us are very excited about getting a chance to work on it. There's a lot we don't know about the rest of the moon, and there's a lot we don't know about in between these various sites that Apollo landed at. And so gathering new information, particularly from the South Pole, but there are many other areas on the far side, that will start to define much more, give us much more information about lunar science. You have to remember that everything we're learning about the moon relates to the very early history of the solar system, and particularly to the very early history of the Earth.
Astronauts have been taking pictures of Earth from space for over 60 years now. More than 4 million still photos and many thousands of hours of film and video have been taken for reasons both artistic and scientific, and to demonstrate to us the changes that the Earth has experienced over the years. Take a look.
These pictures depict the magnificent wonders of our planet. Yet, they weren't taken anywhere on Earth. Instead, they were captured by astronauts aboard the International Space Station to chronicle the fragile beauty and ever-changing landscape of our collective home. To date, over 4 million photos taken by humans from space have been collected, from the earliest days of the Mercury and Gemini missions to the ones taken aboard the space station, and all are freely available to researchers, scientists, and the public worldwide. These photographs are taken for many purposes, from artistic to the scientific, and have proven to have a wide range of uses. A powerful use of crew photography is to study changes to our planet over long periods of time. The Tashka Lakes and Lake Nasser in Egypt, for example, have been photographed on a regular basis from the station over the past 20 years. This is partially because the water levels in these lakes change dramatically on a month-to-month basis, constantly affecting agriculture in the region. Researchers, able to observe these bodies of water over a long period of time using crew photography, can ask, is their volume more or less stable over time? Or are they slowly losing their water? Andrea Wenzel is a geoscientist for the Earth Science and Remote Sensing Unit, who manage requests for crew photography. She notes the flexibility that a crew member offers when taking a picture of Earth. A satellite generally takes the same photos over the same locations in the same orientation over and over. Astronauts, on the other hand, can use different lenses to take photos with different fields of view, from close-up to wide shots. The cupola on the bottom of the space station allows for a panoramic view straight down, or the crew members can elect to photograph an image that includes the horizon. And because the space station flies an asynchronous orbit around Earth, it can capture images at any time of day or night. Wenzel notes that the Vietnam Glacier at the southern end of South America is a good example of a moving Earth feature being observed by crew photography over time. There's been a significant decrease in the glacier's length over the years, and the photos allow researchers to observe the path the glacier is taking, and correlate that to climate change data. The crew can also be asked to capture an event like a hurricane, wildfire, flood, or volcanic eruption. This image shows flooding in Colombia. Wenzel says it was one of a series of photos that was used by international first responders to update their flood maps. As a result, they launched an operation to rescue the inhabitants of local villages who were stuck in place due to rising water. Astronauts often say the most remarkable thing about seeing Earth from the space station is viewing our planet across climate zones and continents without borders drawn on a map. Fortunately for those of us still on the ground, their photographic skills allow us to see what they see, now and over decades of time, benefiting all of us in multiple ways.
And a special treat today, the first episode of a new season of the Down to Earth series. It's not just a chance to hear astronauts sharing their experience of looking down at Earth from the International Space Station, although it is that. But this season kicks off with two-time station crew member Sunny Williams interviewed by a student who knows how to ask the right questions.
Hi, my name is Adrian Prouty and I am studying environmental studies. Today I'll be sitting down with astronaut Sunny Williams. I was curious to know how seeing the Earth from space changed her perspective on the work that she did from space and the life that she lives now once she's back on the planet. Thank you for watching the premiere of Season 2 of Down to Earth. Follow along for more episodes. So I have a few questions, as you might guess. And to start with, I'd like to know what is one thing about living and working in space that most people who have never been to space might not know about or understand?
Well, that's a good question, and I'm not just saying that to fill time. There's a whole bunch of interesting things to talk about. I think probably people think it's pretty nice that you can go and float around up there. But that has some consequences to it, of course. I think our bodies need to adapt to going to space. The initial getting to space, like, whoa, it's a big adaptation, but you feel like we're there. Okay, so now I can float around. Okay, maybe I'm a little clumsy. But I think what people don't recognize is your whole being starts to adapt, and it does take time. Folks had said in the past that maybe a month. I didn't believe it. I think most people don't believe it, but you can really see how people become so natural up in space after about a month and how smoothly they fly, and actually how that translated to me as a reality. It was like, I was like, I don't know what it would be like to walk. When I was up there, there was, through the center of the stack, there was a module that went down, and that was essentially our closet, but it was pretty deep. It was probably like 30 feet down, and I'd float right over it, and I was thinking to myself, I don't even think twice about this. Like, if I was walking, I'd be like, oh, like, what do I have to do here? And I actually sort of forgot what it was like to walk around. That your body, your brain, your body can all just sort of live or change to the environment that you're in. I thought that was pretty fascinating.
That does, it reminds me of the videos that you can see of astronauts when they come back and they're holding something and let go and then it just falls. And
Yep.
That's always
one time and then you go, okay, I got it. Now gravity is back.
Yes. It also reminds me of if you're ever like on a boat for an extended period and you get back on land and then you have the sea legs.
Yep, exactly.
Would you say that, or was there something else that was the biggest adjustment for you in space?
I think that was the biggest. I think a close second is losing things. I think one of the most annoying things is like when you think just for a second, you just let something go, it's just gonna be there for just a second, and you turn around and some air current takes it, and you will see a lot of video of people doing this. And that's because they're looking for something, and that's, I think, one of the most annoying things about being in space. And so good pants, a good flight suit like this with lots of pockets is really beneficial.
What is it like being, once you're in orbit, seeing Earth from the first time from so far away?
Ridiculous. It's awesome. I was actually on the middeck of the space shuttle Discovery that took me up there, and I was working in, we got to space and, things start floating, and that was fun, and I'm chuckling about that. And the commander and the pilot up in the front seats of the shuttle, the commander said, Sunny, come on up. And so I flew up there and he gave me my little wings, and what was more impressive, I was like, oh, that's nice, but looking out the window, I was like, oh my God, there's Earth, and it's round. It's like they were right. It's super cool, and it's just seeing that planet, in that view is just amazing, and you just can't get sick of it. Every opportunity, I think everybody has who lives on the International Space Station. We have this amazing cupola window now. We have 2 windows that look out by the GEM, so you could see the curvature of the Earth from those 2 venues, and it's just compelling. I mean, you can spend all day sitting there watching our planet. Another transition, sort of like your body adapting. Initially, I was always trying to find places that I knew, like Houston, or where I grew up in Massachusetts, or where my dad was from in India, highlighting little pieces and parts of the Earth for the people, which is, of course, very important. Mm-hmm. But after time, I think I started getting more joy out of looking at our planet as a planet. Like watching algae blooms, and all of a sudden in the ocean someplace there's this huge, amazing blue spot, or how the ice forms and flows up in the North Atlantic with swirls, or how the clouds are moving. That was another transition. You look at it like it's a living system. The environment is absolutely living. The oceans are living. It's all changing right below you. It seems like, as we sit here on Earth, we don't see all that happening, but when you look at it from that, macro perspective, finally, it took a little while, but that's how I viewed Earth. It's a pretty cool planet.
And I'm sure it's even more because it's not just the still picture, you're watching it just like grow and transform right in front of you.
Right in front of you, yeah.
Before you saw it from that perspective, did you have any expectations about what you were going to see?
Yeah, of course. I mean, I was, whenever I would get a little bit bummed out here for some whatever reason, missing my family or whatever, I would take a little trek over to Space Center Houston and watch an IMAX movie and go, wow, there's some pretty cool views, but it doesn't even do it justice. I mean, it gave you a foundation, a baseline of what you might see, but when you actually see it for your own 2 eyes, one of the reasons I feel like everybody on this planet needs to take a lap around our planet. Go to space, take a lap, and just look out the window, come back, it'll change your view of things, your perspective.
If you want another look at any of these stories we showed you today, go to YouTube and Facebook at the addresses right there. You'll find them all, along with lots of other great features on a whole variety of NASA topics. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast. It's our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan checks in with Johnson Space Center Director Vanessa Weich as she finishes her first year in charge of America's home of human spaceflight. Go to nasa.gov/podcasts for this week's episode and all our previous episodes, plus the full library of all the NASA podcasts, which you can also find on Apple Podcasts, Google Podcasts, and SoundCloud. You can get the latest from all over NASA delivered to you every week. Go to nasa.gov/subscribe to sign up for the NASA newsletter. You will thank me.